Dimensions of physical quantity. Dimensions of physical quantities can be expressed in terms of any three fundamental units, that is length, mass, and time raised to some power of a real number. What does this mean? This means that any derived quantity, if you have, that can be expressed in terms of a fundamental quantity. Now, this table gives you all the seven fundamental quantities, and here we have the symbol of dimension, meaning that for every fundamental unit we have a dimension. And note that the symbol is written inside a square bracket. Okay, we usually write inside a square bracket like this. And for length, the symbol of dimension is L. For mass, it is M. For the time, it is T. Electric current is I. Temperature is theta. Luminous intensity, it is J. Amount of substance, it is going to be your N. And here nothing is raised to some power. So I told you that it is going to be raised to some power over here, right? If nothing is there, what does this mean? It is meaning that we are raising this to the power 1, right? I can consider that everything is raised to the power 1. Now, dimension formula and equation. The expression which shows how and which of the base or fundamental quantities represent the dimension of a physical quantity is called a dimensional formula of a given physical quantity. The equation which obtained by which equating the symbol of the physical quantity with its dimensional formula is called the dimensional equation. Basically, if we have the dimensional formula and introduce an equal to sign, we will be getting an dimensional equation. Let us take an example and I will be showing you the same. Here we have the question. Find out the dimensional formula and equation for the following. The first one is velocity. Okay, so what is velocity? I know that velocity is displacement over time. So displacement over time. Displacement, what are we measuring here? Basically, we are measuring our length here, and time itself is a fundamental quantity, so I will be writing time. Do we have a symbol for length and time? Yes, we have your symbol L for length, and for time it is T. So I can write that the dimensional formula for velocity, it is going to be what? It is going to be L divided by T, or I can write this as L T over minus 1, or L over 1 T over minus 1. This is the dimensional formula. What is going to be the dimensional equation? So the dimensional equation is going to be equal to the velocity. Velocity is going to be your V is equal to L raised to power 1 T raised to power minus. So this is going to be the dimensional formula for velocity. This is going to be the dimensional equation for velocity. Next, let us consider acceleration similarly. Now, what is acceleration? Basically, can I tell that your acceleration is velocity over time? So this is going to be velocity over time. So time is a fundamental quantity, not a problem here, but velocity, it is not a fundamental quantity. So what is velocity? We know that velocity is nothing but, we discussed in the previous slide, right? So velocity is displacement over time, and we already know the dimensional formula for your velocity. So I can substitute the same thing over here. So what is extra? Extra is your time. So for velocity, the dimensional equation I got was L raised to power 1 T power minus 1. And here I have my T. So I will be writing T over here. So the dimensional formula for acceleration is going to be L over 1 T to the power minus 2. Why minus 2? Because if this T in the denominator, it goes to the numerator, the sign is going to change. Here it is t to the power 1, when it goes to the numerator, it is going to be t to the power minus 1. Both are going to add up t to the power minus 2. This is going to be the dimensional formula. The dimensional equation for acceleration, it is going to be your a will be equal to L power 1 t power minus 2. Let us take one more example. Force. What is force? Basically, we know from Newton's second law that force is nothing but mass into acceleration. Is mass a fundamental quantity? Yes, it is a fundamental quantity, and we have a symbol for that. So it is going to be your m. So for m, we have already, for mass, we have already got the symbol, right? What is the symbol for acceleration? We know from here that the dimensional formula for acceleration is L power 1 t over minus 2. So I can write the same over here. So it is L over 1 t over minus 2. So I can write that the dimensional formula for force is going to be m to the power 1 L to the power 1 t to the power minus. What is going to be the dimensional equation? The dimensional equation is nothing but the same thing. Just you have to add f and n equal to sign m power 1 L power 1 t to the power minus 2. As simple as this. Next, we will be considering for work. How is work defined as? Work is nothing but force into displacement. We know the dimensional formula for force. For the force, it is m to the power 1 L power 1 t to the power minus 2. So I'll be writing down here m1 L1 t to the power minus 2. We already know for this, multiplied by displacement. What is displacement? Here we are just measuring our length, right? So for length, what is the symbol? It is our L to the power 1 I can take. So L over 1 here, L over 1 here. So I can write this as m over 1 L over 2 t to the power minus 2. This is going to be the dimensional formula for work. However, the dimensional equation for your work, it is going to be what? It is, I can write like this. For your work, it is going to be equal to m1 L2 t to the power minus. Next, pressure. What is your pressure? Pressure is force divided by area. We know the dimensional formula for force. It is m1 L1 t to the power minus 2. So let me write the same thing over here. What is area? Basically, area is nothing but length multiplied by length. So can I tell that it is L multiplied by L? So L into L, I'll be getting L square. So I can write this as ml1 t to the power minus 2 divided by L square. Now, if I cancel the L in the numerator and the denominator, I'm going to get m L to the power minus 1 t to the power minus 2. This is going to be the dimensional formula for your pressure. However, your dimensional equation, what will be your dimensional equation for pressure? You can write your pressure. This is going to be equal to m L to the power minus 1 t to the power minus. I hope this concept is clear.